I need to go back and open this in an earlier version of Unity so that I can actually show it working, because right now, literally all you can do is just walk around the world, and I get throw your fishing rod. But the way that I built this on the back end, I think is the piece that I'm trying to trying to tie with this explanation to why I'm working on what I'm working on right now. So let's take a quick peek under the hood, and I'll show you guys what's happening. So what I've got is this local player, and the local player is kind of the top level controller for all of the game logic. And local player has a bunch of these things underneath. It has these canvases that are for each different piece of the game that has, different UI sets, all that sort of thing. And when the game starts, you can see that local player will instantiate, once I go online here, it'll instantiate a player object. So this player object is the piece that is interesting. Animator. Here we go. So because what's happening is the player, I actually use an animator to control his different states. So you see when I move to walk, he transitions to the walking state. If I go up here to this place, then he'll fish, and he's on this fishing layer. He currently is fishing, and you can see if I go through these, he kind of transitions through these different states. So these states I'm using to explicitly control the game, how the game plays. So on each of these, there are behaviors associated with what's going on. So where's my behavior set? Oh, right. So these behaviors are being driven by these parameters, and these parameters come from here. So actually, this is the one that I should have been showing you. So what I was showing you was the animation behaviors. So, however, there's a equal or like kind of a mirrored piece on the local player, because this is networked, where when you're doing these things, it will keep control of kind of where you are and what you're doing. So here's the big one for players. So right now I'm idle, and I can be walking, and the idle state has this SMB is short for state machine behavior. I have the state machine behavior on it that says when you're in the idle state, we'll just jump over to here, do these things, and it's a set of, on enter, you kind of set up some animation parameters. Then while you're updating, go through here and see what the joystick's doing, change that to, hey, if you're doing an interaction, then set a trigger to start fishing or be at the merchant, or go back to idle if you're not doing anything. Similarly, so, hey, if you're walking, then in here, if you're walking, do these things, move the player around. Then if I go up here and I start casting my rod, you see I went to the casting minigame, and now I'm in the awaiting bite state. So the casting minigame, same thing, has its own set of update parameters. Now, I think that it's super clear and really easy to kind of create new behavior and combine pieces of code that I've already written and just be aware of what's going on in the game. There are a number of challenges with using Unity's animator this way. Number one, I don't think this is what they intended it for, and so there's a bunch of kind of gotchas that I'm trying to fix. Things like you can't transition more than one time in a frame, and you don't get it's hard to get certain callbacks about like, hey, which state are you in, or when you enter the state, do these other things as passed around within the animator itself. So if you want to take two transitions on different layers at the same time, that's just it's really hard. Or if you want to say, hey, only take, I know that all of these conditions are true, but only take one of these two transitions. Don't take both of them at the same time. So like, for instance, for some instance, if you were at a merchant who was next to the water, and you were in a position where you could do both of those things, then a naively implemented controller would just open up the merchant menu and start you fishing at the same time. And coordinating that behavior in the animator that Unity provides is more difficult than it needs to be. So one of the things that I'm building in my own editor is just to make that easy. Anyway, So then the other piece that is pretty cool about this thing that I built is so in here where you're defining all your behavior, uh, when you actually do something like, let's say set the item sprite name. I think that this is one. So this is a custom property. That's right. Let's find something that is just set locally here. So these are good examples. Let's just take position. Position is pretty straightforward. So position, you can see, is implemented as a property, and what the property does is it is probably something you haven't seen before, which just says bus.set. So there's this other tool that I wrote called Omnibus, which is available on GitHub if you want to check it out for yourself. And Omnibus is a tool that lets you propagate changes in values through the Unity graph. And it just makes it super easy to control things like, I don't know, like position, for instance. So I'm trying to find where this is actually used. These are all... Okay, so here's one. So this position 2D module is part of Omnibus that says, hey, I'm going to hook myself up to a bus and grab the value from position. A bus is just it's a key value store. So from here you can see it stores vector 2s, it stores booleans, it stores, just whatever. And it looks like this. So any of these values, when I actually run the game, you can see that these things will start getting updated. So as I'm moving around, you can see that the position value is changing. And same thing, camera position is also changing. It's got this anim walking that will toggle on and off. And same thing, like which direction is forward. All that stuff on this player down here is just automatically hooked up by adding different modules. So the position 2D module says, hey, I'm grabbing from the bus over here. I'm grabbing the position value, and whenever the position value changes, I want to update my own position. So I didn't actually have to write any code to change the position of this object. I just said, hey, push this value into the bus, and then whatever's listening to it, those things can do whatever they want with that information. So that is the data flow part of Harmony, the new library that I'm writing. And that's why I'm writing this, is because it kind of puts together these two ideas that I've had. One, you explicitly drive a lot of your behavior through state machine, and two, you propagate changes in values using a graph, using data flow. So as I've become more formal about my thinking in this, what I've realized is that what this is actually doing is it's separating two kind of modes of programming. So you can have programming in the declarative style or programming in the imperative style. Declarative style programming is things like, when this is true, this should be true. When I move the position, your sprite should update its position. When I'm set the walking flag, you should run the walking animation. That's declarative. Imperative is do this, then do this, then do this next thing. Then if this is true, do this thing. Otherwise, do this other thing. That's like one step by step. That's imperative. And each piece is good for something different. So, but I haven't seen a tool that allows you to use both at the same time, at least in the way that I want. Usually things like state scripts, the scripting language behind Overwatch, they'll kind of mix the two together and not make either. And usually imperative will become the first class citizen, and declarative is kind of like, oh yeah, and then we have this declarative piece too. So, but I think there's some really neat stuff that you can do when you make both of them just first class and treat them both independently, but allow them to interface with each other, which is what I'm trying to do with Harmony. Okay, so let's get back to some actual development here and not just debugging the Unity update. So